even unmuted. Sorry. Anyways, yes, so we've gone through the setup, the installation, and the project structure. Now we're declaring the pieces. And so we're declaring it this way because of object-oriented principles. And as such, remember how account can be inherited by account saving or like check or whatever. So the same way how our pieces would sort of inherit from piece, because every single piece you have on the board, they run different logics. However, innately, they are just the same thing. They're just some object that is holding some kind of image. And whether like the rules that sort of govern how they move, that could be an entirely different thing that will sort of describe each of them uniquely. But in the back, they're all kind of inherently the same. So this is what we're going to try and implement. So let me just put this. What we're going to do now is start creating these pieces one by one. We want a pieces folder. And within this pieces folder, we're going to create a class called piece. And like the earlier examples, we're going to create some initialization of the piece. Every piece is defined by its color, self and color. But for what we will be passing in, it's mainly just the color. So we want to make sure that each piece assigns itself the color that we set it to, and also some kind of abbreviation. And what abbreviation is here? Well, it's just a thing that we define. So it doesn't really mean much, but we need a way to sort of like turn it into a string. I should have made this bigger. I'm so sorry.
Sorry, my eyes are just really, really bad.
Nah, I get it. It's fine. Even I can't see the one in the back. That's all right. But yes, that is how we're doing it. So, and also just one more thing, if you ever get lost or like I'm too slow or I'm too fast, feel free to refer to the wiki that we've already mentioned. So here we have two things that it sets. And now I want to do something called a string constructor. And what that is you notice how Python, you could print a list and the whole list just comes out. We kind of take that for granted, to be honest, because print is usually only defined by the primitive data types. And as such, it wouldn't know how to print a list because like a list is like slightly more advanced than like maybe an integer or a string. And because of that, every sort of like data type, data structure, they have some kind of like defined stringify. And for us, we want to be able to print out a piece. And what would that mean? It just means that we want the abbreviation we set to it. That's all. And then for the possible moves, this will be a implementation we do later. This is more logic. And this will just process all the possible moves. We'll do this later. And then we want to get a place. So we want to place a piece on the board. That means that we'll have the piece and we want to have a method that puts it on some kind of board. And that's why we have this here. So we'll handle this later. Next, we are going to start defining our pieces now. Let's get a pawn piece setup. So likewise, let's do a constructor. And it's kind of recognized it here for me. We want every pawn to have some color. And this is a form of inheritance. Realize that a pawn is basically a piece. That's why we're calling a piece constructor. And you're passing a color. So it just knows to set itself its color now. And then self.abbreviation. We want this to be P. Oh, like we've called it P. But yeah, let's do this for pawn, knight, rook, bishop, queen, and king. I'll give you like maybe 5 minutes in case if you haven't done it. I'll be doing it here if you need like a little hint. So let's just take 5. Yep. If you have any problems so far, please just raise your hands and let us know, or like just look for us, the people who are like running the workshops. All right, I'm assuming most of you should have that down. It's literally just copy and paste and then just change up the variable names. So I think we should be all right. Okay. Any problems so far? Guessing not. All right, let's move on. So what we need next is the board to put these pieces in. So let's start with creating the board. So we can create a new folder within here. Let's just call it board.py. So this is the board, and then we'll like define some kind of board here in a bit. But the board itself, there's quite a lot of things we're gonna have to define as like the construct. So let's maybe break it down a little bit. Let's think of the board itself, or every single square. How could we store each of these squares? Any ideas? Should it just be like a string? Or like a list dictionary? Well, I'm gonna suggest that we use a tuple, whatever. Essentially it's a coordinate, like how we've usually seen it in graphs, like an X, Y sort of grid. And with that, let's define each of these pieces, its location, X, Y, like on a two-dimensional grid. And then we want this coordinate to be a separate class because we want to be able to do something with them. If it was some kind of like variable, let's say if we did like x equals to a1, it's a bit harder to make transformations on them. Let's say if I want to move this, like I guess you could, but like it's better if this was a class instead, because this is better defined and then it's more strictly typed. So then you can't really accidentally just like, oh no, I want a P in my board, but that doesn't really work. Boards are only A to like G or H. So let's create the class to hold our coordinates. So we'll create like a little file called utils. This is just like a file. If you don't know where to put your functions, throw it in here, it'll work. So let's get board coordinates. And we define the initialization of it. And let's make it so that coordinates must have an x and y, such that the self x is just x, the self y is just y. And let's make sure that they actually pass in an int, because if Python kind of just treats it as a string, so we don't really want that. We want actual numbers. And next, let's talk a little bit about the board representation. We have the little coordinates for each square, but now we want to hold the entire board. So one way we could do that is sort of by using a dictionary. I'm hoping you have heard of that before, but our dictionary is going to be formatted like this. We're going to have some dictionary that holds like a location and then like a piece. Oops, bad handwriting. So that's kind of how we'll hold our entire board. Just it's easier to look at it that way. But later on, I'll mention something about how like why you may or may not want to do it like this. So let's just create like the board. And if you're familiar with chess algebraic notation, this will come a bit in handy. So on the y-axis label, let's hard code this. I want the tuple. So these. So I want how chess would normally notate it as like from the bottom A, B, C, D, E, F, G. And then the labels would go from left to right, 1, 2, 3, 4, 5, 7, 8. Next, let's make sure that's defined within our board coordinate. So I'm going to move this up here. So if we want to print board coordinates, what do we want out of this? Does anyone know? So if we print this, what do we want? So we're going to want to get it to push out the coordinates. So literally just turn everything to a string. Luckily, it kind of just knows how to do that. So, sorry, it doesn't really know how to do that. We're going to have to bring in something called letter notation. And then upper. Because it's currently like a 1 to 8, 1 to 8 kind of tuple grid thing. And we want it to be able to push out like a A2, for example. So let's make a function that does that. So if you pass in something stupid, so not in bounds. Whoops. Pass in something stupid, get something stupid. Easy. Then we want everything. So now that we know that it is a valid coordinate, let's make it return the y-axis first and self.call. And that's just the column of what we want. And then we're going to want to string this. We also want to string this one such that we get the x-axis. And we want the int of the row. Sorry? Oh, yeah. And then just don't. Stuff.xy. Oh, you called it row column, is it? That makes more sense.
Yeah.
So that's row and that's column. Oh, I thought this was the missing function.
Yeah.
All right. So now you can kind of see how when we pass it through, it'll sort of just convert itself. And whenever we print it, we're going to see in a very nice like A2, A3, B3 sort of notation. And so that means we can now move on to actually generating the board. But if you've ever played chess, you know that chess starts in some specific configuration. We can do one of two things here. We can hard code the entire configuration. So we can create like a dictionary. We start from the bottom left corner. It's going to be a castle. I forgot what it's called. Whoops, I haven't played chess. And then it's like you can define each location, hard code it. And then it's literally just like a huge constant here. We could do that. Or with a bit of smarter object-oriented principles, let's use something called the Fed notation. This is what it is. If you played chess on chess.com. You might have seen this before if you ever try to export your state. And what that is it's a string that will give you the entire board state, whosever turn it is, what valid things it could do, and like how many turns till it terminates. It'll give you everything you need to be able to start from that specific state and move forward. So if we have a look at this is sort of like Venn notation right here. It's a bit confusing, but I'll just quickly talk about it just so it's easy. I'll open it up here. So if we look at this example, all this is saying, we'll quickly do this through. That's the website there if you need it. Here is the first row, and each letter sort of denotes like the piece. So I think there's rook, knight, bishop, king, queen, king. That's first row, second row, empty, 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 empty. And this is the other color, which is why it's a different capital state. And then these aren't really of a concern. It's not really a problem. But after all the rows, you sort of get the turn, the player turn, whose turn it is to play. And then this is castling rights, if I'm not wrong. This is en passant, if there's any opportunities for that. And this is number of turns in total. So if I play once, the other opponent plays one, that's 2 turns. And this is the total turns. If we both play once, it means 1 turn has passed. So because I think there's a draw limit at 50 or something, 50 full turns or 100 plays. So those are stuff you could implement. If you choose not to, it's fine. We won't be, I'm not sure if we're implementing it, but yeah, so we'll be mostly concerned with the first 2 parts because that gives us a state and that tells us who starts. So let's try and implement this. We will have to use a library to help us out because it's in a string, and I don't know about you, but strings are really annoying to like play with. So few things you want to grab. These are the things. RE here is regex. If you've never heard of regex before, you're probably happier than us. So regex is sort of a way to deal with strings or string searching. You can pattern match all of these, and there are very annoying notations to sort of pattern match. But that will help us sort of find the gaps between everything when it's all exists in one blurb like this. And also don't forget to import board coordinates because it's a different file. Your Python wouldn't know like where to find this board coordinates thing. So make sure you include that. So, all right, just to save some time, I might copy this one over. Feel free to do that, or I'm just gonna talk about it. If you type fast enough, you can follow along. But here's the gist. So we're gonna initialize myself as a list of empty positions and an empty state because there's nothing on my board at the moment. And then we start with white. White always starts first. And then we want to load the initial state. So we have a string here, the Venn notation, and we want to load that. So let's start by defining what load could mean. We pass in some kind of configuration, so the entire string. And what we want to do is we want to configure it by splitting it. So notice how it's sort of in blurbs, blurb 1, blurb 2, blurb 3, blurb 4, something like that. So this first one, or index 0, is what we want here. So this is index 0. This is the entire state, mainly what we're working with. And this is regex. It's basically saying, if I'm not wrong, expand the blanks between like a specific character. So some digit here, which is 8, we want to expand blanks. Expand blanks is a function we're going to implement later, which is why it's shouting at me at the moment. And if not, you just want to like make it whatever it is. It's if else statement right there. And for self position, there's nothing in there. For every row, I want to check every column. So every letter that you see here, every row, I want to check each of these. And what I want to do is that if it's empty, it's whatever. I don't have to add it. Then I'll grab the coordinates. I'll convert it to the letter coordinates. So like maybe B3. And then I'm going to enter it. So generate piece here is a function I'm going to write later. So I'll talk more about it later. And then this is to put it down, which we have not defined. And this is just defining turn. So if it's white's turn, it should be W. If not, it'll be black. Can someone tell me why we're doing it this way instead of like just hard coding? I know I've said that like it's better principles to like not hard code stuff and all that, but like there's a few cool things we can do with this. Does anyone want to take a stab? Yeah.
After we move, we can save it as a permutation and then
Mhm. Yeah, exactly. So you can extend this. Remember, every time you write some kind of big application, keep in mind that you may have to extend it in some way in the future. So you want to make it easily extendable. And that is an object-oriented sort of like mindset. So one cool thing is you could save this, and now you always have a state where you can practice from. Another cool thing is you can generate stupid boards like this, and then you can now enter this and have a just have a go and see if you could actually beat this. I don't know why you would need 3 horses, but whatever. So you can play with that. And there is also another cool thing that arises from this. And this is a little hint for Hackathon if you do join. Hackathon is our hackathon that's coming up 2 weeks from now. So there is this idea in artificial intelligence called the state representation. Because if you think about it, if you ever try to do some kind of like game bot, so you want to create a bot that sort of can like win at a game, you start at some state, right? And you have like your board, but every piece you move generates a new state. So you could move like a rook, you can move the second one, move the third one, and then you have like this really, really big board that only gives you the first move. What if you want to search everything all the way down until you find a state where you actually win? This is crazy big, the state. It's still something that's being researched on. And if you try to start a dictionary here, God bless your computer, it's not going to be able to hold any of this. So one way of, well, you could cut or whatever, but one way of actually helping you to save all these states is you could maybe, instead of holding a dictionary, try holding a string. So that is quite a big hint if you ever want to do anything that's like artificial intelligence kind of thing, or maybe even for hackathon, because that is way too big for a computer. Turning that into something else will very much help. So that is also another thing you could try implementing. So instead of the dictionary we've created, we've used the dictionary here for our locations because there's no bot involved, but you could also try converting it into some other kind of notation. And if you're interested, look up bitboards. That's the bit version of string. So there are some errors here, which I said these functions don't really work because we've never implemented them. Let's implement these. So we can start with expand. And we'll just take in some pattern to match. And if we get like a blank, we just want it to like space it out. The reason why we're doing this is because regex takes in a function, and this function just tells it to, well, give it some space. That's basically what this is doing. So now within, sorry, this should be outside. This is just like a helper function. So now within the class board, we can define a few things. So let's grab a few functions that will help us. Get rows. And we want like that string of positions. And then just split up. Then the same thing, get columns. And then we use the split up the other way. Does anyone know what this underscore means, like at the very front? Notice how I put an underscore in front of get. Do y'all know what that means? Do you know what that means? Yeah, so there's this concept of like privacy in object-oriented where like certain things should be able to access. Like let's say if I run the main file, I want to be able to just call these functions here. But sorry, this is cell empty, my bad. So yeah, certain things you want to be able to do that, certain things you don't want to be able to do that because it means that you're showing too much of the internal program. And one way of doing that is to just use conventions. So this underscore just tells us, hey, please don't call this if you're not in this file specifically. And then we're just checking if this is empty. Whoops. Yep. Any questions so far? Guess not. All right, moving on. We want to be able to generate pieces. This function is still not done yet. So let's create that over at pieces. And let's define such that every piece can be generated. So this takes in a letter. And if you pass it something stupid, so either a none type or nothing, or if you try to give it something more, don't do anything with it. We'll probably be catching these errors later, I believe. But so now what I'm gonna do is, this is just a bunch of if else statements. I'm just gonna copy this over. And what this is doing is, let's start by defining whose turn it is. So we'll look at if it's uppercase. If it is, it'll just do whatever it needs to. Yeah. So define whose turn it is. And then just turn it into uppercase, because now we want to just do checks for what piece it is. And for every possible piece, let's just make sure we return the right kind. So if you're P, just return pawn. So that's for everything. Next up, we want to make sure we import this over to board, because we're going to be using this in board, not pieces. So back over to board, we want to be able to use this function. I just realized this shouldn't be in a class, right? Yeah, this is just a helper function. So let's just throw this down here. There we go. Oh, my mouse. All right, so now this function, bring it over here. So, whoops, pieces. Yeah, just bring it over. And then we want another function that sort of just returns all the positions. So now we're just putting it all together. We want this thing to return us all the locations. If you're used to dictionaries, this is exactly what we're recreating, honestly. So within board, we define a function called items. And then we return the state. And then states is just a dictionary. So give us the items in the dictionary. How are we doing on time, Daniel? About, okay, yeah. All right. So that is basically it for the underlying background part. Hopefully it's been pretty clear. I'm gonna do a quick little overview on Tkinter. You don't have to follow this if you don't want to, but you can if you want a little reference point. So Tkinter is sort of the GUI which we're using. It's pretty big. There's a lot of implementation. Sorry, not documentation. And I'm just gonna talk a little bit about like how you could use it. So with Tkinter, you could create a window. And this is just the constructor for creating the window. And then we need like some kind of main loop, because with graphics, essentially it's just a refresh of a picture. And if you do that fast enough, you'll kind of just you'll see like moving things. So if I do that, yeah, see, there's a little window, it's refreshing, it's whatever. Oops, ignore that, please. Ugly background. Anyways, so that's that. And the way Tkinter sees it is just the widgets.
Might not working. Keep going.
Okay, really. It's working.
Oh, it's just not close enough, I guess.
I think so. Yeah, so widgets are just
Yeah.
essentially, I think I'm not loud enough. I think I'm pretty loud. No?
No, it's not clear.
Widgets are just the little elements you want inside your GUI. So since this is just a little demonstration, I think I'll just copy this over. This way. I don't think it makes a difference. Copy this over, but title. So you could actually just, if you have like something that shows you all these things. I don't know if it's built in for your editor, but mine has this. You can see there's like so many different kinds of things you could be doing. And this is just saying create a title. This is the size. And then I want to add like a text. And then this is just to put it together. This is the button, put it together. And then now we have like a main loop that should just have like very basic things. This is what we'll be using. So let's get into it. So let's start by importing everything we need. Let's get a GUI set up. So within this GUI, let's import inter SDK and pillow. If you remember earlier, we only need two things. We don't need the whole library. So let's grab image TK and image just to help handle with our image. And then we want like a little class. So this is just setting up the chessboard. Our chessboard will have a bunch of innate properties. So what could they be? So let's have a look. So for the frame, we want to make sure we want to make sure you initialize with a few things. So super, if you're not used to this term, it's sort of like calling its parent. So the same way how pawns could call pieces, this is just what this is doing. We're calling its constructor. And then I want the pieces to have nothing for now. Icons, you have nothing for now. And then let's instantiate rows to be 8, columns to be 8. And then I want to set your image size. And then the next few things are just sort of, they're what you need to set up sizing and stuff. So don't worry too much about it. So we want that multiplied by the square size. And then the height, same way. Yep. And then now we can pass this in. And this last part, I should have just copied this in. I'm just gonna do that right now. But this last part is just more like setting up stuff. Yep. So you've essentially set up like a little, like just the size and everything, how you want it to look. But that's just the shape. We still haven't actually pushed it out yet. So we're gonna need like a function to do what main loop did. And we can call it something else. So let's call it display. So with this, I want a chessboard. And I wanted to make sure that you're passing in a board. I have to, okay, I'll install that later. So I should copy this in because this is a bit out of scope, but that's just specifically how you would implement it if you're working with a GUI, but that's just set the title and then pass in everything you need with all these parameters. I believe board is here, right? Yeah. So over here, I just want to make sure I import. Yeah, make sure you import board. If not, this won't work. Do I need chessboard? Okay. Sorry. Permanent argument. Whoops. All right, there you go. Easy. Yep, now we want to draw the pieces for each piece. So within this, I'm also gonna copy over. I'm sorry for copying all this, but like there's not much I can say here. So for me to draw pieces, I want to delete everything that's on the board. And then for everything on like items, remember how we made it so that if you just call the board items, it just spits out like a dictionary. And so it'll give me the card piece as like the key item pair. And if it's actually a valid one, make sure you pass me everything and then I'll draw it on. That's all that is doing. I need to refresh this. Yeah, and then since this thing is screaming at me, let's go create this over at utils because I don't know where else to put this. All right, let's define a function using this. It takes in a coordinate. And I wanted to convert it, that's all. So grab this. It's basically just, I feel like we've written this somewhere. I can't remember. Oh, I know, but this is index. Slightly different, but same idea as the other thing. There we go. So it's indexing. Don't worry too much about it. And then next, let's make it so that it can draw us the piece. So over here, we need it so that it can draw the piece, add a piece, and then place a piece. These are all very, like it's just, because it's putting a piece on like a grid and that the position is very finicky. This would honestly just take you a bit of trial and error if you notice like why is there like some weird adjustments by the square size or whatever. So that's kind of how we've arrived at this. So don't worry too much about it. So back over at GUI, let's put this now. I believe, yeah, these are two different functions. So draw piece for the piece, and then this adding it, and this is placing it. So feel free to copy that over. All right, so that's the pieces. Do we actually see anything if I call it right now? Fair enough. All right, fair point. Oh yeah, you are very right, Daniel. So from utils, import this. So now this function works. I'm just gonna move on. We want like a checkered pattern in the back. So like you see how in that you would have the pattern. What is my mouse doing? So yeah, this sort of background. So we have a couple of functions just to get the coloring of it down. So copy this over. And under GUI, we want this square background. So just depending on like what's next, and then like it'll set the size of the square, and then it'll like create a rectangle with those parameters. Just copy this in. It's a lot to take in, but it's all right. And next up, remember how I mentioned that a video is just like a bunch of pictures and you're just quickly going through it. We want to make sure that it also updates if you do something to it. If not, the moment you click on it, it's just going to redraw and it's like back there and nothing's going to happen. So let's set up the function for that. So let's create a function called refresh. It's this one here. And refresh just redraws the board. It calls the functions for it and it basically just goes through the whole thing and like cleans everything and make sure that it gets drawn again. So that's what this is doing. I think I'm going slightly over time, so I'm going to speed this up a little. But yeah, that's refreshing. And once again, we're going to need board coordinates. So that is utils, I believe. So add in board coordinates here as in your import. So you get no errors. Happy. Additional functions, how fun. Right, so we're almost done. So let's initialize this. Within init, let's give ourselves some color. So one can be white. And then second color can be gray. Yes. And then one more thing we want to add is just the configuration. So within the canvas, I'm going to bind this configure. What is this? I don't know, to be honest. You could probably look it up. It's somewhere. And then I believe it should be okay, except for this one little function here that's screaming at us. So let's fix this function. We'll just add it down here. Where are you? Yes, so for this function, I wanted to take in the cards, so specifically bar coordinates, and just give me the color. So we're going to do a bit of smart Python thing. Is this supposed to be capitalized?
This white color is great.
Yeah, but never mind. Too many brackets in this thing. Cards. So we retrieve the row minus the column. Modulo 2. Make it so it doesn't run out. I believe this should be. It's not defined. It's you define it later.
The hyphen. If you can define it now.
Isn't that in it? So it's supposed to be this, right? So I'll just change this to this. Right? Yep. So I'm referring to the stuff here because these are my variables and they're not like floating somewhere. So that's it. And then the last one we'll do is just checking if it's inbounds from earlier. So within utils, over here, let's make sure that we can tell whether something is inbounds or not. And I believe board size is just 8. Yeah. So we can just define a global variable here that says 8. So yeah, we are done. Let's create a little main file. Sorry. Let's create a little main file. So let's create, make sure it's outside and not inside the folder. Chess.py. And within this, we're going to want to import 2 things. The chess libraries GUI. We import display. And then from chesslib board, we want to get board so we can play with the board states later. So we've made it easy on ourselves. The tree is called board. Epic. And then we want to display the game. 4 lines of code. Who knew it was so easy? So let us do chess.py. If it doesn't, oh, it's screaming at me. Cannot import display. Ooh, that is a lot of errors. Oh, wait, no, that's not from me. There we go. Okay, so it's just this. Let me quickly fix this. And these 2 private functions. It's frozen runtime. Cannot import name display. Oh, these are all in the board GUI function. Did you mean board GUI, not display? Sorry, folks. Quick debugging. I'm gonna do a quick thing.
No.
Hmm?
Go to GUI.
Yep.
Search display. So this one.
It's like down. Maybe.
It should be outside of the class.
Okay. Yep. My bad. This, just put it at the bottom and just make sure it's outside of everything.
Also 107 for self.
There you go. It's out of everything.
107. 917. So no.
In here, is it? All right, let's see if this runs. That is not the right one. And something else is screaming. Regex. See, this is why you're happier if you don't have to deal with regex. Next one. In not string.
Change in string.
This is the py. So we're looking at yep. Sorry, folks. Hang on. Does it work for you all, or are you getting these same issues? I don't know. If y'all tried running this, it should be mostly okay. Let's see. Oh.
I don't think you need to not in it.
Huh?
I don't think you need to please not in it. I think you can just please.
Yeah. But like that was the only thing that screamed at me.
Self, comma, color.
Oh.
Two arguments.
Yeah. Okay, enough debugging.
Oh, okay. If nothing call, it's not in string.
Board.py. Do you want to come join me?
You can open that one.
Mm-hmm.
Go to the repository.
Mm-hmm.
Like, yeah, go to the repository. So, go to temp. Yeah.
Temp?
Yeah.
Temp's working?
Yeah. I just updated that.
Okay.
Yes. I know. It's
Wait, am I supposed to check out? What's the error? It's showing at me errors.
It's
Does it work on yours?
9:30. Wait. 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 What's in 9:30?
Self state that they call it.
No, what's function? What function is that?
Load
Can
bar
load.
py load. Does it work on yours?
Yeah.
Can you just plug yours in?
Okay. Oh wait, no, no,
Sorry?
mine's 11, it's on the
Like, oh, you don't have it.
Yeah.
It's alright. Does this one work though? Alright, if yours works, you should get like a board which is just empty, if I'm not wrong.
Yeah.
There's chess pieces, right? Yeah, okay, I didn't get that far. So there should be a bunch of chess pieces on there. You shouldn't be able to do anything with it. But if it's not working for you, same way how you installed this repository, if you're like me and you didn't get it to work, go over to temp. There's this branch called temp. And this is what I should have done so far. So I think my computer is having some issues, but you should have something like this. If yours works, then congratulations. If yours doesn't, go over to temp, just copy this and then like git clone this. Then you should be all right. Okay. Thank you, everyone. We'll take a 10-minute. Okay, then we'll start at 150-ish. Like we'll try and start at 150. If you need help, let us know. We'll come around debugging right now.